when we talk about applied, we like to talk about it as these three pillars: the top talent, the total technology, and the absolute adaptability. On the talent side, we like to think we can get the best talent out there because our engineers are full-time engineers. We don't hire consultants who are only on a project basis and then leave at the end of the project. These are full-time employees of ours, and so there's no downtime for them. And we've done some really interesting and exciting IT projects for customers as well. And we're a 100% employee-owned company, so everyone has a stake in Applied success. On the technology side, we have the best tools in the industry, but our services consultants can also use any other tools as well. And like I said, we've developed some really interesting IT infrastructure projects. And as far as the adaptability, we are really flexible in the length of the project we can do, whether we're working on-site or off-site, the size of the project that you're working on. So we'd like you to think of us as very adaptable, very versatile, able to do whatever project that you need. We like to think we can fit into your organization the way that it works for you. So the takeaway message from all of this is, I like to tell people, a lot of companies, at least their HR departments, like to lump us into the category with a consulting firm. And I'd like to say we're not that. We're an engineering firm made up of engineers, started by engineers, and run by engineers. So we want you to think of us as an engineering arm extension of your company. So there's one more short video that we're going to play for you now. This is on our website as well.
Whether you're talking about people or mechanical parts of a machine, one thing is certain. In order to work properly, they have to fit. A square peg in a round hole? Nope. Oil and water? Not going to happen. At Applied Engineering, it's our business to make sure that we fit with your plans, people, and projects. We achieve this by combining top talent, total technology, and absolute adaptability, creating a custom solution just for you, when you need it and where you need it. Why Applied Engineering? Well, we thought you'd never ask. You see, the speed of business can be a complicated mosaic of custom software, machines, and computers, and sometimes you need a team of professionals to help you navigate it. That's where we step in. It takes the right people with some of the best minds in the business to help you turn your ideas and dreams into physical products. Our team of engineers will work with your product development team to design your product, fitting within your timelines and budgets. Then we work with your manufacturing team to improve processes, design tooling, optimize workflow, and increase efficiency. And to increase overall productivity, our programmers will write custom software to replace spreadsheets, secure your data, and give you the information you need when and where you need it. Our talented team will help you implement industry-leading design and manufacturing software, saving you time and money throughout your design and manufacturing processes. We reduce the paper pileup by digitally scanning your large format drawings and blueprints and making them searchable and accessible. We install and support industry-leading servers, storage, backup, and networking equipment to help keep your data secure, accessible, and efficient. We're the only firm with the talent and technology to fit your project, your process, and your culture. Our ability to be adaptable to any work situation allows you access to our technical experts directly, so support for your engineering and technology system is only a phone call away. We also offer standard classroom training on a variety of engineering software, as well as customized training to fit your unique needs. Visit one of our training centers, or we'll bring our mobile training lab to your site. By providing engineering and IT expertise, as well as software, IT infrastructure, and training, we virtually and literally support every facet of your product's lifecycle. Applied Engineering is the modern solution to your engineering, design, or IT challenges. Our dedication and commitment to fitting your timeline, budget, and specific project scope is something we stand proudly behind today and have since we started doing business in 1986. We are the only firm with the talent and technology to fit your project, your process, and your culture every time. Visit GoApply.com to learn more about how we can help you or how you can join our team.
So the takeaway message I'd like you to take from that video is that we can do a lot of the different parts of your design process. If you need help with your concept phase, we can jump in and do that. If you need help with the concept and design, we can do that. If you need help all the way through setting up a manufacturing line, optimizing manufacturing, handling your data, writing some IT software to manage your data, we can do a lot of different parts of that. So talk to us about our capabilities, and I don't think you'll be disappointed. Now that's all of the header material that I have to introduce you to Applied. At this point, I'm going to turn it over to Joe to talk about the whole design engineering process and the pitfalls you fall in. One last thing, if you have questions throughout, go ahead and ask them through the use of this webinar tool, and we'll see those questions and we'll wrap them up at the end and answer all your questions at the end. Okay, so I'll turn it over now to Joe to talk about the meat of this presentation.
All right, thanks, Lincoln. Good morning, everyone. Thanks for joining us today in the second session of our Applied Day webinar. Just to give you a little background on myself, like Lincoln said, I've been here at Applied for quite a while now, 19 years, my whole career. The first 10 or 12 years of that I spent working on projects for our customers, both externally and internally, right inside their engineering department. So between that experience and my experience here recently, or more recently, I guess last 9 years, it's not that recent, of working on the front end, some of the sales, pre-sales stuff that I've done, I've got to see a lot of different companies and a lot of different industries over the years. It's really my favorite part of my job. I get to go and see how all sorts of different things are made, and more specifically how they're designed. So when they asked me if I wanted to do a presentation for Applied Day, I was excited about it, but I was a little overwhelmed too. Design engineering was the subject, and it's a giant topic. I don't think a 20-minute presentation I could really cover everything you need to know about design engineering. I've been doing it for 19 years, and I still don't. There's still plenty to learn out there. So I kind of approached this as just trying to bite off a chunk that we could cover today, and maybe provide you some information that I've learned over the years that might be beneficial to you, maybe different sections that hit home with what you guys are trying to do at your companies. So
Can you just switch back over to this one? This one's still okay.
Sorry about that. I had this thing all set to go, and then of course as soon as we hit showtime, the whole thing freaks out on me and I forget what I'm doing. So so here's a quick outline of what we're going to talk about today. This is my subjective view of the design process as we most commonly see our customers go through it, and how we go through it ourselves on projects that we do internally here at Applied. So we're just going to talk quickly about each one of these sections and give you a little definition of how I define them, and then we'll talk about one or two pitfalls that you might run into and that we've run into over the years for each of these sections of the process, and some tools that you might be able to use to overcome those pitfalls. So we'll get started here with concept. The conceptual phase of the project is the beginning, obviously. For us, we're always working with customers. We're working on their products. So for us, that starts with a kickoff meeting. We sit down with the powers that be at the customer and the people on our team that are going to be working on the project, and we hash it all out. We have a plan going in of how to get the information we need out of them, and we do the best we can. We try to get everybody that matters in that room for that first meeting and get as much information as we can, because the pitfall that I want to highlight today in the conceptual phase is heading down the wrong road. And heading down the wrong road is an easy thing to do on the conceptual side of it. You basically do it every time you do a concept, pretty much. The trick is to figure out that it's the wrong road early in the process. If you spend 3 or 4 weeks working on something and come back at the end of it and you were going the wrong direction, that's going to be a pretty big error for most of our projects. We don't ever get that far before getting back to the customer and checking in that we're on the right path. So in in a more standard engineering environment, it's the same concept. Everybody needs to be involved. That's going to be a stakeholder in the project, and there's got to be a very defined, judicious way of getting the information to start a project. So this one's all about communication, both directions. If there's good communication up front and the engineers and designers on the team, the engineers and the designers on the team have the information they need, they're not going to start going down the wrong road. They're not going to get too far down that road before they figure it out. And vice versa, the engineers and designers, the design team, has to be communicating what they're doing all the time. And a lot of this comes down to project management right off the bat. If the project manager has got things together and is facilitating that communication, you're going to have a lot of success. And we focus on that a lot here at Applied, is making sure there's a project manager assigned to every project and that they can communicate in both of those directions. A quick example of this type of issue is back from my career. Back in the old days when I was working on projects, I did a long-term project with a automation equipment customer of ours, and I came in to help them design a new line of machines in a 3D CAD package. They were just switching over to 3D, and they needed some engineering horsepower that understood how to use a 3D package, and that was me. So I got paired up with one of their design engineers, and we worked together on that project. And we had a project manager doing exactly what I was just saying. He was facilitating the communication between us and the stakeholders in the project. We really only ever talked to him. He gave us tasks to do, and he let us know what we needed to get him. And then he would come back with changes in direction or what we needed to do. And the whole thing went smoothly. We went through a bunch of different concepts, narrowed it down to the best one, and then he had to leave. He was actually from England. He had to head back to England. So he left the project, and that position just disappeared. We ended up dealing with the people that he had been dealing with. And at that point, the project went back in time, basically. We started reviewing all the same concepts that we had already talked about between the three of us, and we pretty much went through the same exact process. And about 3 months later, I came into work, and me and the other engineer were just talking. We realized we were back to that very same starting point. So that was a 3-month trip down the wrong road that wasted 3 months of time and 2 people's engineering hours. So that turns out to be a lot of money. That's kind of an extreme example, but that's the risk you run if you run into this pitfall. Obviously, some tools you can use to overcome this in the beginning, since it's all about communication. CAD packages in this day and age, like Autodesk Inventor, have communication tools built into them for making it easy to communicate with people, especially people who don't have access to that package. So you can send 3D models to anyone via email, and they can open it up on their computer no matter what software they have loaded. They can spin it around, look at it, mark it up, send you back their thoughts on it, all sorts of things. There's another quick tool I wanted to highlight. It's called it's Autodesk Sketchpad, I believe. There's a few different ones like that, but they're used to actually sketch on, and you can take them into meetings and you have a monitor there, and you can sketch on that monitor, and it inputs that sketch directly into your CAD system at the end of the meeting. So you can sketch real time right in front of the customer, and then you can turn it into utilize it in the design afterwards. So that's the conceptual phase. After the conceptual phase, we come to design, what I call design 1. I wish I could say there was a real hard and fast line between those 2 phases, but really they blend together a lot at this point. You start moving on to the design area of some portions of the design, while you're still might be conceptualizing other portions of it. Design 1 is basically when you start really getting the nuts and bolts of the design together. You start laying out all the features of the design, getting all the components in there, making sure everything's going to fit up. You start thinking about materials. You start thinking about the whole thing, and you start putting it together. Where in the concept you might just have things to take up space for certain sections of it that you're not worried about. You got to start getting those things dialed in. You got to start worrying about how you're going to put it all together, if you're going to weld it, if you're going to bolt it. All sorts of things like that come into phase in design 1. So design 1 is really a critical phase. A lot of work gets done at this point. And a couple of pitfalls that I wanted to highlight. The first one is loss of control of the design. Early on in the project, sometimes you're operating outside of outside of some of your normal control systems, your production system or your PDM system. And the design teams can get going and be storing their own hard drive. They can be storing things outside of the normal channels. So you can lose control. You can lose control at this point of the CAD data, and you can kind of lose control of the design itself if you have multiple people working on it and they're not communicating well enough. So I think, one other thing I wanted to mention about losing control is duplicating parts. And some of our bigger customers that do more larger assembly type engineering design, and by that I mean assemble to order instead of engineer to order. It's a huge portion of that engineering process is making sure you're not duplicating parts. So if a part exists in the system, you want to make sure that you find that part if you need to use it again, and you don't create another one. Every time they create a part at some of these larger engineering companies that we work with, it costs them X amount of dollars. So they spend a lot of time and a lot of effort to make sure that they have effective ways of finding those parts. And some of the tools you can use to overcome that, a big one is going to be your PDM system, Autodesk Vault type of system. That's obviously going to organize things for you a lot better than just storing files on your own. It's going to make sure you're going to have control of your revisions. You're going to have control of your check-in, check-out procedures, things like that. And that goes right along with the second tool I wanted to mention, which is your process control. You just have to make sure that your engineering department is set up with efficient processes for this part of the design, and that you train everyone in to the point that they follow those pretty specifically. Next pitfall in this section is kind of one you might see a couple times in this presentation, but it's wasted time. It's kind of a general term, but there's some specific things that happen, I feel, in the design phase that can waste a lot of time, and you want to make sure you're keeping an eye on them. One of them, I would say, is over-designing, spending too much time getting everything dialed in just exactly perfect, maybe on one section of the machine or one section of the product that you're working on, while ignoring other things that need to be coming online at the same time. It doesn't do you any good to get everything dialed in on one section of the machine when you still have work to do on another one. So you have to make sure that somebody's keeping an eye on the overall view of how things are going and assigning resources correctly, so that you don't get stuck with a bunch of extra hours, extra work on a portion of the design that might change anyways, or might get affected by something that's going to change later. Another thing that wastes time is just the slow pace of work. There's many reasons that work happens at a slower pace sometimes. It might depend on who's on the team. It might depend on their training, things like that. So there's some obvious tools you can implement there to overcome that issue of the slow pace. Training is one of them. CAD training or design training, project management training, things like that. Keeping your team members trained up is critical to being able to keep these designs on pace. Sufficient hardware and software is another one I wanted to mention. The way the software packages are these days, you have to keep your hardware up to date. We try to run on a 3-year cycle for our engineers and designers, and that's the absolute maximum we want to go, because at 3 years, these high-end workstations we're buying are getting to be pretty old for running CAD. So we try to make sure everybody has a new machine every 3 years, and with a group of 65 to 70 engineers and designers, that gets to be kind of a never-ending cycle. But it's critical to doing this type of design, and the benefits you get from it are worth it. Designing in 3D and all of the tools that these software packages are adding all the time, tools and features, it's definitely worth it, but it's a drain on the hardware. The hardware is always trying to keep up. So after design, we move into prototype test 1. And I have design 1 and design 2 and prototype test 1 and prototype test 2. These are, like I said, this is kind of subjective. There's no hard lines here. Some companies might just have one prototype and test phase and then go straight to production from there, or maybe some companies will have more than that. So just in general, talking about the early prototypes and testing phases, this is where you're going to start worrying about the problem areas you see in your design. And I shouldn't say problem areas, but the challenging areas of your design, where you want to make sure section 1 of your design works correctly. So you figure out a way to build a prototype that's going to test that theory. It might not necessarily include a bunch of other stuff from your design to save time and save money, but those would be areas that you're more confident in, the areas you don't have to worry about. So at this point, you're prototyping the critical parts of the design. And I think the big pitfall here is spending too much time and money doing this. It's easy to fall into the cycle of building a prototype and then going back and seeing a bunch of cool changes you want to make and updates you have to do, make those changes, then build another prototype and see how that works. It's tempting to fall into it because you can get everything dialed in so well, but it's expensive. And it's kind of a vicious cycle of going back and forth through that process. So the main tool I'd like to highlight to overcome that would be finite element analysis and simulation software. Everybody on the call is probably somewhat familiar with FEA software. We do quite a bit of it here at Applied, and over the years I've been involved in quite a few of the projects. I told Lincoln just the other day as I was putting this thing together that I felt like I could do 30 to 45 minutes just talking about the different types of FEA packages out there. It's a really interesting topic to me, so I'm just going to try to give you an overview of the options. So in your CAD packages, most 3D modeling software like Autodesk Inventor has a built-in FEA tool, and those are what we would call kind of the base packages. They're going to do your static linear type analysis, where you just want to. They're great for just checking stresses on something that doesn't move, just highlighting specific areas where you're worried about the basic stuff, making sure that your factor of safety is high enough, things like that. If you get into anything more complex than that, any type of nonlinear analysis, dynamic analysis, things like that, usually that's going to mean you have to move up to a higher level package, an Autodesk simulation type package, which is one of your higher level FEA softwares out there. So that's actually the point where a lot of times we help our customers is when they get out of that linear static range, they come to us to work on the higher level nonlinear stuff because it's a little bit out of their range. If you don't do a lot of it, you can't have somebody qualified to do it sitting around for most of the year just to do a few analyses. So that's where we help out. And that's a big part of it that I wanted to mention is you got to have somebody qualified to do these analyses. A lot of us could sit down and figure out how to set up a study and how to load it and how to constrain it and get results, which is great, and they look great, and it's actually, if you're like me, it's kind of fun to do. But there's no real substitute for experience on this, because just because those results look good doesn't mean they're right. You can put garbage into an FEA system and get garbage out and never know the difference unless you really, really know what you're looking for. So that's one thing I always like to stress people is that the FEA packages are getting easier and easier to use, but you still need an expert to be able to interpret what you're looking at. FEA can show you a lot of things on a design. It can show you, the obvious thing that everybody looks for is the stress strain that you're seeing in your design. That's the hot spots versus the cold spots on the design, and that's great. But there's more to it than that. You can see deflection issues. So if you have tight tolerances somewhere, or if you have something hanging out a long ways, you can tell how far that's going to deflect, and maybe if it's going to cause interferences, or if you're going to bottom out somewhere that you didn't want to bottom out. You can switch materials out quickly. So you can take the same design and run an analysis with 3 different types of materials and see how that affects it. So instead of going back and redesigning the entire thing to take care of some hot points in the stress side of it, you can change materials very quickly. Obviously, cost savings is a big one. Once you get through looking at an FEA project for the spots you're worried about, the factor safety spots, the high stress spots, you can look for the low stress spots and see if you can take some money out of the design, reduce the material thicknesses, just get components out of there, because every quarter-inch of material that you put on some designs costs a lot of money, and every different part that you gotta add in, that costs a lot of money. And the last thing is just reassurance that when you build that prototype, it's gonna be structurally sound and gonna work relatively the way that you want to. And a quick example of that one is this product here, or something very similar to this. This was done quite a while ago by one of our customers when the Dreamliner was coming online for Boeing. They won a bid from Boeing to create inspection unit that would go inside the Dreamliner fuselage. And the trick with the Dreamliner was it was a carbon fiber fuselage that was all made out of one piece. So these things came out of the manufacturing facility in one piece like this, and then they cut the holes in for the door and the window, and there's still a ton of things that had to be done inside that fuselage. So the machine that our customer was building contained a boom just like this red one you see here. It was a 60-foot boom, structural boom like that, and to get the fuselage into place, they had to cantilever that boom out 60 feet and slide the fuselage. You can see that white cart down there. I think that's the cart that carries the fuselage around, and they slide it over the top of this boom. Then once it's in place, they support the far end of the boom, and they do their work inside the fuselage. They designed it up. They were pretty happy with it, but they were pretty nervous about what was going to happen when they cantilevered that boom. So they came to us, and we ran an FEA for them, and a couple different versions of it, and we're able to tell them we found a couple hot spots as far as stress, but they really knew what they were doing when it came to boom design, so it wasn't anything too critical on the stress side of it. But what we were able to tell them is that the end of the boom was going to sag. And this was a while ago, but the numbers were very, very, very close to what I'm going to tell you. I think the FEA predicted it was going to sag 2.39 inches, and months later when they got the boom all constructed and cantilevered it for the first time, they measured it, and as accurately as they can measure it, it came out to 2.30 inches. So it was a pretty amazing, pretty impressive example of what an FEA system can do, not just on the stress side of it, but on the deflection side of it. But that gave them presence, or kind of a reassurance going into building that boom, because they weren't building both prototypes; they were just building one. But that gave them the reassurance to go in there and get that thing built and be sure it wasn't going to drop to the ground the first time they cantilevered it out there. All right, moving on. Design 2. So after these initial prototypes and you get through that, crank it through that design 1 phase, you get to design 2, and that's the back end of the design cycle. And the main pitfall that I wanted to highlight here was detail drawings. Detail drawings, nobody really likes to talk about these anymore, I get the feeling, other than those of us who have to work with them and produce them, and the guys on our team that are working on them all the time. It's just not a flashy topic that comes up all that much, but they're still a huge part of what we all do every day, and they're the main way that things get built, and they're the main way that your design gets communicated. So, and they're time consuming. That's the big thing. That's the pitfall. You can spend a ton of time making the detailed drawings for your design, and it can hog up a huge chunk of this design 2 phase. And there are, one thing Lincoln mentioned earlier is that we can help, and we do help our customers in any facet of what I've been laying out here, from conceptual all the way through to release and even beyond that. So there's projects where all we're really doing for the customer is that what I would call this design 2 phase. We're doing the modeling, and they kind of have the design cranked out, but we're spending a significant amount of time modeling and then doing the drawings for them too. And it always amazes me how much time we have to include in there for the drawings. Even projects where we've just been redoing the models, like remodeling from a 2D system to a 3D system, we put in at least as much, if not more, time to do the drawings than we do to do the models. So it's a lot of time spent on them, and they're very important. There's no getting around them right now, or very rarely is there a way to get around them. But it's something you got to focus on, and you got to train your people on, and really make sure that your drawing standards are taking efficiency into account, and you're not getting overly concerned with all the processes and everything that's got to be on your drawings to get the point across. As long as you're taking the efficiency into account and making them as easy to do as possible. I think you can save a lot of time in this area. Some of the tools you can use to overcome this pitfall. The first one, the dream that everybody's been talking about for a while is to get rid of them, is to have the CAM packages out there that can build off the models right now, and they are in use. They haven't, in my experience, haven't really taken over the industry yet. I've seen examples of it where our customers just send the models to their suppliers, or they just send their models out to the shop. Seems to still be fairly limited, but as we go, it's going to save a lot of time on that drawing side of it. With all the metadata included in the models, there's no reason that you can't get everything you need off of that model, as long as the guys out in the shop and the people running the CAM system can understand what they're looking at. Another approach that some of our customers have taken is to automate the drawing process, and you can even automate the design process too. If you have a product that's fairly similar from one project to the next, it's kind of not the same thing over and over again, but it's not huge differences on the design side. There are products like Autodesk Inventor ETO that can automate that whole process for you. A lot of companies just start with the drawing side of it, so the model will get created to exact specs with the exact information needed on it, and then the drawing process is created manually. Some companies, we've seen examples of people setting up interactive websites on their website where the customer can come in and put in the specifications that they want for whatever the product might be, and a product like Autodesk ETO comes in and builds it from scratch. They build the models, build the drawings, and you have a full packet when you're done. So those are some of the newer things that I think the industry is transitioning to. But like I said in the beginning, detailed drawings are still extremely important, and I think we're all wise to not ignore them quite yet. So we're getting to prototype test 2 phase here. So these would be the final prototypes that you're looking at doing for your design. This is when you're getting close to production, being production ready. And the biggest pitfall you're going to run into here is the non-production ready parts of the prototype, especially if you're talking about some of our bigger customers that are doing assemble to order type production. They go through a long development process, and at the end of that development process, they do a pilot run, and that's their last prototype, and they run it down the assembly lines, and they want to have everything as close to production as possible, because any issues that you're going to run into after that, or a lot of the issues you're going to run into after that, are going to come on the things that you didn't prototype exactly like you're making. It's not always plausible. You can't always have production tooling up and running for that type of test or that type of prototype. Sometimes lead times don't work out, but the goal is to get as close as you possibly can. And one more interesting story, or interesting customer project that we helped out with was this one. This is the Chernobyl reactor site. It's the new containment system for that reactor site. The life of the initial sarcophagus that they built at Chernobyl is coming to an end. So this project has been going on for a while now to build this containment building. And what you're seeing here is the actual building going up, and it's being built a certain distance away from the reactor. I can't remember how far it is. But the building is going to get all constructed, and then it's going to move. It's going to slide over the reactor and be fairly remotely operated. There are very rarely going to be any people in there, I believe. So our customers, part of this project was to build inside that building. They designed and built the giant overhead hoists that go in there and are remotely operated. Well, these things are enormous. I mean, it's hard to tell scale here, but that building, I think, when it's done, is about 3 football fields long. So their cranes are up at the top of that, a couple hundred feet off the ground, and 900 feet long. And so prototyping something like that's not really realistic. No, not too many of our customers have a prototype bay that's quite that big. So what this company did, they still believed firmly in the prototyping process, especially this last one, to get all the bugs worked out on the software and the controls and everything. They knew they had to be able to run this thing themselves in their own shop. So they built a scale model. And one of our engineers was assigned to design most of that scale model. And I can't remember what scale it was exactly, but it was still a pretty significant machine. And they went through the whole design process with just that prototype. They went through the whole thing, designed it up, and got it built in their shop, and were able to test it and debug it out. So they didn't have to try figuring everything out the first time they built this thing over in Russia. So it was an impressive project, and it always stuck out in my mind as to how much they invested, how much time and effort they invested to get that prototype up and running in time to learn how their machine was going to work. So that brings us to final design and release. This is the tough part. This is when you're getting right down to the nitty-gritty, and all of us as engineers, we get into those details and we can get lost. And it's not just us; it's everybody. It's the whole industry. It's hard to finish these things off. There's a lot of stuff that needs to be done all the time, and it feels like you're never gonna get there. But what we find that our successful customers do is they drive it through this to the end here. They accelerate to production because you got to draw the line somewhere. As long as the machine is safe and you've got the main parts of it designed the way you want it, then you have to you just got to accelerate through, and you're not going to be able to change everything you want to. It's tempting after that last big prototype. It's tempting to go back now that you've seen the actual production machine, basically. It's so tempting to go back and make a big change and say, I wish we could have done this, or I wish we would have done that. But that's very risky, and it's very expensive, and you have to stay away from doing that. One quote I've heard a couple times over the years that I thought was always fitting is, in the development process like this, the first 90% of the development takes the first 90% of the time, and the last 10% of the development takes the other 90% of the time. So this last 10% really can be a time waster. That's the biggest pitfall you're going to run into here, is just wasting oodles and oodles of time on trying to get everything finished up. So that brings us to the end of what I wanted to go through today. But this is the end of the design process and the development process. But it's not the end of the road for the engineering world. We all know that. And at Applied, we do a lot of work with our customers in the continuous engineering department too. After things are released, it's a never-ending process to keep improving them, keep making upgrades, getting things fixed. So I think the final point here is that this is just kind of the start of another long road that I don't think we probably have enough time to go through today. So that's where I'm going to finish it up. Like Lincoln said, if you have any questions, feel free to type them in, and we can go through those now.
Go ahead, one more slide. Did we get any questions in, Joe, during the presentation? I thought I heard one come in. I don't see anything. Don't see any questions. Okay.
So shoot something in quick if you'd like to talk about it. Otherwise, if anything we talked about today kind of struck a chord with you, or you'd like to talk more about it, or talk more about some of the tools we talked about, feel free to give us a call anytime. We're always here.